We're doing 1.7, day 2. We're going to start with number 29. So if we are doing number 29, give me just 1 second. I'm going to put this over here. It's over here. So if I'm doing number 29, the first thing it asks me to do is sketch the graph of F inverse. And I know that F inverse, I just look at the line y equals x, and I reflect across the line y equals x to find points on F inverse. So that means if the point 6, 2 is on F, then the point 2, 6 is on F inverse. Maybe I'll make it in red to make it clear. So 2, 6. If the point, what's this point? So if the point 2, 0 is on F, then the point that's on F inverse is going to be 0, 2. So I think this graph is going to go like that. So they are mirror images across the line y equals x, where you switch the roles of x and y. Okay, so that's 29, and it wants us to find f of 6 and f inverse of 2. So f of 6 just means when you plug in 6, what do you get out? Well, we get out a height of 2, so this is 2. But then it's saying if you undo 2, so if you undo 2, what did you have to plug in to get out a height of 2? Well, you must have plugged in 6. Because f of 6 is equal to 2, that's why f inverse of 2 is equal to 6. F inverse of 2 is equal to 6. If the graph is shown, find the domain of f. So the domain of f appears to be from 2 out to infinity. And it looks like the range of f, just for completeness, looks like it's from 0 to infinity. So because I know those, that means I automatically know that the domain of f inverse is, the range of f inverse. The range of f inverse is going to be the same as the domain of f, so it's going to be 2 to infinity. But the domain of f is going to be the same as the range, the domain of f inverse is going to be the same as the range of f, so it's going to be 0 to infinity. So we switch the role of x and y. Our x's turn into our y's, and our y's turn into our x's when we're talking about inverse functions. All right, so that is all of 29 through 32. Okay, so let's see. What else do we have? We have 37 and 38. So 37 and 38 are talking about this picture right here. They want to know what f of 1 turns out to be. Well, f of 1 just means for the input of 1, what output do you get? Well, that would be 0. And then for 38, it says solve f of x is equal to 3. So for an output, here they're saying x is equal to 1, so what is your y value? Well, here they're saying y is equal to 3, and what is your input? So for a y equal to 3, our input must have been 7. So in this case, x is equal to 7. Then it says, for 39, it says find f inverse of 0. Well, if you're trying to find f inverse of 0, you're saying f of x is equal to 0. So for what x did you plug in to get out 0 is really what that's saying. So if you ask what f inverse of 0 is, what you're really saying is, what did you plug in for x to get out 0? And we see that the answer to that is x is equal to 1. So f inverse of 0 is just equal to 1. So that's your answer. Okay, and then for 40, it says solve f inverse of x is equal to 7. So f inverse of something gets me out 7. In other words, f of 7 is equal to what is what it's really asking. So what is an output that gives you an input of 7? Well, for an input of 7, what's your output? So for an input of 7, what's your output? Well, the answer would be 3. So that's why this is 3. Okay. So the answer to this is that x is equal to 3, and that's how you would solve that. Then 42. So 42 says if f of x is equal to 3 over x minus 2, it says find the inverse and then graph it, the function in its inverse. So we're going to do that using Desmos. But for right now, let's just find the inverse. So this is really telling you that y is equal to that. So first I'm going to switch, and then I'm going to solve. So first I switch the roles of x and y. And so I get x is equal to 3 over y minus 2. And then I solve. So one way to solve is maybe I multiply both sides by a y minus 2. As long as you do the same thing on both sides, I think you're good to go. So in that case, you get y minus 2 in parentheses times x is equal to 3. Well, then you can divide by x. I think as long as x is not equal to 0, I think we're saying that x cannot be equal to 0 in this case. And then we get that y is equal to 3 over x plus 2, right? And so then it wants us to graph. So f inverse of x would be 3 over x plus 2. And this is f. If we graph them on the same axes, I go to my old buddy Desmos, and I'm going to graph 3 divided by x minus 2. And then I'm going to graph 3 divided by x, 3 divided by x plus 2. And we notice that if you graph y equals x, they are mirror images about the line y equals x. Pretty cool. So that's really what we have here. Done. Save the photos. I'm going to take it in here and just paste it right here. Pictures, paste. Looks like that. So in this case, y equals x is a screen line. So which one is going to be my original? So just help me out. My original is in red. So my original is 3 over x minus 2. And then my other one is in blue. That's my 3 over x plus 2. Y equals, maybe I call this f of x. I call this f inverse of x. Okay, so that's 42. We also wanted to do 43. So for 43, if f of x is equal to x cubed minus 1, that's the same as saying y is equal to x cubed minus 1. So first thing we're going to do is switch. And then I will solve. So I switch the roles of x and y, because that's what it means to be an inverse, and then I solve. So by solving, I guess I'd add 1, and then I would take the cube root. Notice there is no plus or minus, because we took an odd root. Odd roots, you don't have to worry about plus or minus. So here's f, Here's f inverse. So if I go cube root x minus 1, so I go back here, and I go the cube root. So let's see, functions. See if it's got a cube root. So let's go with the cube root of x plus 1. Cube root of x plus 1. Cube root of x plus 1. That was my second function. So I'm going to pull it down here. And then my first function was x cubed minus 1. X cubed minus 1. And we see that they are mirror images about the line y equals x. And I could even make it a dotted line if I wanted to by going here, here. Let's make it black and dotted. Let's make this one. Maybe I make this one red and this one green. All nice Christmas colors. There you go. So that's what this thing looks like. I say done with a save photo. And I go back in here and I paste it. Pictures, paste. A little bit smaller. And so here, again, the red one was our original. So in this case, f of x is equal to x cubed minus 1, which makes sense because I've memorized what a cubic looks like. This will be f inverse of x is equal to the cube root of x plus 1. They are mirror images about the line y equals x. So for example, you have the point 1, 0 on our original function. That means that the point 0, 1 is on your inverse because we switched the roles of x and y. That's it. Have a great day.